Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we are talking about variable loading for the chapter 11.7 from the Shigley Mechanical Engineering Design book. Okay, in this all the pictures is taken from the book itself and from Google Images, and the content is taken from the book itself. Okay, so let's start. What is a variable loading? Okay, variable loads, bearing loads are frequently variable and equal in some identifiable pattern. Okay, piecewise quantum loading in a cyclic pattern, quantity variable loading is a repeatable cyclic pattern, and also random variation. Okay, what is the meaning of piecewise? You can see in Google, if you search in Google, it says that it's a mathematical function that where to solve this function, there are many sub function to solve it. This is how the mathematics says. Okay, but what is the meaning of variable loading? It's just like you drive a car, kan? When you drive a car, of course, sometimes you slow down, sometimes you ram your car, sometimes you go faster, sometimes you go slower, and then sometimes you go 10 kilometer per hour, sometimes you go 20 kilometer per hour, sometimes you go 40, sometimes you go 60, sometimes you go 100 kilometer per hour, and then this is variable. This is variable. It will affect your bearing, it will affect your bearing and everything. So the question is, in the previous video, we are talking about loading is constant loading, meaning that let's say revolution 100 revolution per hour, 1000 revolution per hour, that is a constant. But now we're talking about uh, at the first stage, at the first stage it goes for slow, and then it goes for medium, and then it goes for slow again, and then go for higher again. And this is variable. This is what I'm talking about, variable, and how to select bearing that is suitable for this variable equation. This is okay. This slide will tell you about it. Okay, so FA L equals to constant K, where F is the force, the load, equivalent to the steady radial load of or for a radial thrust load combination. In the slide in the previous video, we learned about equivalent load, and then figure 11.9 is a plot of FA as ordinate and L as abscissa and everything, and then you get okay, you can read all the text, okay, and then is this is figure 11.9. You see here is the variable load. Okay, theory. This slide want to tell about how to make the theory for the variable load. Okay, LA is the measure of damage. Okay, we'll talk about damage in the next slide. Okay, this is the piecewise continuous cycle. You see here, this is what I mean by the variable load, meaning that I give example of a car, of a motorcycle, of a bicycle that you ride. Of course, some at some stage you ride slower. At some stage you drive your car faster, and then slow again, and then faster again. And this is variable. Okay, how to calculate, how to select the suitable bearing for your application. This is the question. Okay, so D is the damage per period. Okay, this will be I will explain in the next slide. Okay, okay, where L is number of revolution of life, Li equivalent steady load, F equivalent when run for L1, L2, L3 revolution does the same damage D. Okay, D equal to this. Why it say damage? Okay, why it say damage? Of course, they use the book use the word damage because eventually you have to change. Like for example, the nearest example to you is your car, is your motorcycle. You have to do maintenance. You have to change. A certain period of time, you have to change lubricant, you have to change oil, you have to change the bearing and everything. You have to change the timing belt. timing chain and everything. And then what indicator that the bearing has come into its life? Okay, this is the indicator is the life itself. Okay, when you go for service your car, the mechanic will say that this car can go for 10,000 miles. Okay, 10,000 miles you have to change, and when you change the oil, you have to change. Maybe you have to change something else. Okay, and then this is called the damage because in the end you have to spend some money, and you have to spend some money to do the maintenance. But it is a nature of that. Anything we have the maintenance. Okay, any equipment you have the maintenance. Motorcycle, car, your machinery, all have maintenance. Okay, so this is called the damage. Okay, loosely called the damage lah. Okay, so this equivalent, you can see this equation is the life fe for life, meaning that you can say that the, let's say for this part you drive slow, this part you drive medium, this part you drive faster. These all the part have this certain range. This is the equivalent part, this is the equivalent part, and this is also the equivalent part. And then what is the this is all the equivalent, and F1 is a fraction of revolution ramp up under load. Okay, that is what I say. This is certain period of time, this is certain period of time, this is certain period of time, meaning that it present certain revolution, and certain revolution of bearing speed and everything. And then you total up, you get this equation, and 1 per A, remember, A equals to 3 for ball bearing, A equals to 10 over 3 for cylindrical and taper bearing. Okay, okay, this is the equation. The example, I must remind you, when you do this example, you take quite a bit lengthy time because you have to calculate and everything. Try to understand. Okay, try to understand. You may spend at least 15 minutes to do this example. Okay, okay. Let me explain how to do this example. A ball bearing is run at 455 condition, steady load. Okay, column 1, 2, 3, 4, 5, 8 is given. When you do this example, you have to draw back again. You have to calculate back again. Okay, draw right back again this table. Then you can, because the answer is you have to calculate and you have to put your own value. Okay, column 1, 2, 3, 5 to 8 is given 1, 3, 5, 8, and then column 1, 2 multiply to obtain column 3. 1 and 2 multiply, obtain column 3. Okay, ni 10.1 times 2000, you get this. Okay, and then column 3 and 3 is divided by the sum of 3. Okay, column 3 divide by 3. Okay, pergi column 4. And column 5, 6 are the radial, axial and equivalent load. Column 8 is proper application factor. Column 9 is product of column 7 and 8 times 7 and 8 times, you get this. Okay, okay. And then application factor is 3, radial load Fe, and then you get this equivalent load is 84 pound. Pause this video, try to do this equation, try your best to do this equation. Okay, try your best to do this example because it will take at least 15 minutes. My experience when I teaching last time, 15 minutes you have to spend to do this example alone. Okay, okay, after they understand, then you go proceed for this slide. Okay, linear damage analysis. The question after cyber loading is how much life less number of strike is held until failure. Failure occurs when linear damage hypothesis, then D equals to K. Okay, so this is the equation for linear damage analysis. FAL, D and K is constant. K equals to this equation. Okay, meaning that let's say I try to explain in simple analogy. Let's say your car have to service. The time for the service your car is up. You have to service. You have to service your car, but you don't service yet because you have you have to use the car because and then you extend, you purposely don't service your car yet. You have should service this time at this time period, but you don't service yet. Okay, you don't have to change. You cannot change the go for service yet. Okay, for whatever reason, and then uh, your equipment needs service, but you don't service yet. So how long can it sustain before it totally damaged? Before it totally damaged. Okay, there is a question mark. Okay, so this is the linear damage analysis. Okay, sure, you can run your car, you can drive your car exceeding the service limit, but how long can you run your car uh, exceeding your service limit? Okay, this is the question. This is okay. So this is like analogy I've given as linear damage analysis. Okay. So load variation, question advanced by Paul Magran in 1934 and Raymond Miner in 1945. Okay, this is the equation, and this is the different damage done by during rotation angle. Okay, you can see this equation. Example, curve of bearing rotate will come through the angle. Okay, then this get this equation, integration equation. Okay, from this equivalent load, you can obtain equivalent load as life equivalent K equal to F equivalent. Remember, to get this you have to do the example 11 point something that I said, that you have to spend 15 minutes to do this. Okay, and then the value of D often to pi, and numerical integration is often useful to carry out the indicated integration. Okay, you have now learned how to find the steady equivalent load that does the same image as continuously varying cycle load. Okay, this is the continuous load variation for cyclic inertia for spirit is theta. Okay, this is an example. Operation of particular rotary pump involve a power demand P. P prime is a not sin theta, where P prime is average power and P is the same variation, and develop an application factor. Develop an application factor for this application for ball bearing. Okay, this is the picture of the pump. Okay, so this is the equation. Okay, you put uh, you have to you have to have the calculator with you. You have to have the calculator with you to do this equation. Okay, put all the value that you get, and then you get the application factor as this. Okay, in terms of application factor is AF equal to 1, 3 over 2, A over F. Okay, then you get this equation, and then the solution you can tabulate the tabular form. This okay, okay 0.2, 0.4, 6, 8, and 1. This is the solution. Uh, okay, and that's all for this video. We see you in the next video for selection of ball and cylindrical roller bearings. Okay, do the example. Okay, do the example in this text in this video. Okay, okay, thank you very much.